Right, we are back again. So we have the question 2023 paper 2 CCA. Question reads, in a geometric progression, the second term is 21 and the fourth term is 189. Calculate the first term and the common ratio. Sixth term, sum of the first 5 terms of the progression. Okay, so now in this case, the first thing that we need to do is let's have our solutions. So we have solutions. So now in this case, we have question 1. So mind you, in paper 2 we have the geometric progression. That's the subtopic under sequence and series that comes in an exam. So paper 2 we have is GP, geometric progression. So now this is now quite right, geometric progression. So the first thing that we need to do is we analyze the question. So we have been given that the second term is 21. So the second term, we use capital letter T. Second term is 21. And then we have also been told that the fourth term is 189. So the fourth term, so you write T4 to show that this term we are actually representing is term number 4. It's the fourth term. So this 4 is the position of the term. So 189. Okay, we have 189. So now they are asking us to find the first term. So first term we don't know, as well as the common ratio represented by small letter r, we don't know. Okay, so now you analyze the question. So how are you going to do it? So now in this case, when you look at the sequence that you have been given, the terms are not sequencing. They are not following each other. They are not in order. So what you need to do is here use the nth term formula of the geometric progression. So the nth term formula of the geometric progression is T n equal to a small letter a to represent the first term, and then n to the power n minus 1. So that is the nth term formula. Okay, where t is the term itself, n is the number or the position of the term. So if the term is number 4, meaning the value of n is 4. If the term is number 5, is the fifth one, meaning n, the value of n is 5. Then a is the first term in the sequence. Then r is the common ratio. N is the same as the position of the term. Then minus 1. So I'm going to substitute this. Since term number 2 I have is this one, and then term number 4 I have it's 189. So I'm going to substitute this into this formula for each. Okay, so that I form 2 equations. So I start with the first one. So this first term or the second term that we have, it's C. So where there's n, I'll replace 2 to show that this is the term which is on the second position. And then first term we don't have, and then common ratio we don't have, and then n we have it's 2 minus 1. Okay, now in this case we have been given that the second term is what, 21. So where is t2, the term itself, I'll replace 21 equal to a to the power 2 minus 1. So that's what I have. Okay, then from there I now do what? I now simplify this. So we have 21 equal to a r 2 minus 1, it's 1. So here there's no need of writing to the power 1, just leave it like that. So mathematically that is not right. So but in the actual sense, we have to know that this error is raised to the power 1, but we can't show it. Okay, so we leave it there. So you will say, okay, this is equation 1. So we move on to another one. So another one, we have the fourth term. So the fourth term, where there is any, I'll use the same formula. So where there's any, I'll put 4 to show that this is the fourth term. And then A we don't have, and then R, where there's any, I'll replace what? 4 minus 1. Okay, so since we have been given the term, the fourth term is 189. So I'll put 189. I'll replace 189 there, equal to AR. So here we also do the same. So in this case we have minus 1. So we have 189 equal to AR. 4 minus 1, we have it's 3. Okay, so it's to the power 3. So since the power there is above 1, so we show that the AR raised to the power 3. So you name this one as equation 2. We have two methods that you can use, either to find the first term in this case or the common ratio. It's up to you to choose which one. So I'm going to show you the shortest method that you can use to find either the first term or the second term. Okay, later on, if you would like, you'd request the second or the other method, I'll still revisit the work and do using the other method. Okay, so for now we can go for this one. So we have formed two equations here, this one and this one. So what we're going to do is, I'm going to get equation 2 where I have a bigger term and also the bigger power. So in this case, 189 and AR to the power. Here I have the power of 1. Here I have the power of 3. Here I have 189. Here I have 21. So I'm going to get this equation. I'll write it here. 189 equal to AR to the power 3. And then I'll get this equation where I have smaller, okay, variables of smaller powers and also smaller numbers, which is the term itself. I'll get it and put down here. And then I have AR. So in short, what I'm saying is I'm dividing this one, the smaller one, into the bigger one. That's the concept. I'm dividing the smaller one into the bigger one, Okay. So now I'm going to divide this constant number into that one, and also this one into that one, also this one into that one. Okay. So I'm going to divide. So there are some instances, some situations where the number can't go direct into that one. So in that case, you just have to look for the number that you can divide in both this one and that one, and then remain with a fraction. But in this case, if 21 can go into 189, so I'm going to divide using 21 direct. Okay, so now here we go. So 21 into 21 is 1. Then 21 into 189, it's 9. Then this A and A cancels each other. And then here I have 3 R. So in this case, it simply means R times R times R. And I have 1 R down. So if I cancel 1 R into 3 R's there, I cancel 1 there. Meaning I'm going to remain with 2 R. So meaning what I'm saying, I'm going to remain with R into R1. R there, so I'm going to remain with R raised to the power 2. So now you just write what you have remained with in this case. So what have we remained with? So in this case, we have remained with on top there. Here is just same as 21 has gone, is 1. So 1 and 2, 9 is 9. So we have remained with 9 equal to, A has gone, has cancelled out already, has already been cancelled out. And then R have remained with the, or we have remained with the R to the power 2. So to find the value of R, just introduce the root both sides. So this root cancels each other. You remain with R equal to, the square root simply mean the number that you can multiply twice or 2 times and then get 9, and that is 3. So meaning our common ratio is 3. We are done with the common ratio. So now to find the value of A, you pick any equation of the two and make sure that you don't pick the complicated one. So we have, I'll get equation 1 there, 21 equal to AR. So I say 21 equal to A is the one that we are looking for, times R we have is 3. Okay, so 21 equal to A times 3, it's 3A. Okay, it's 3A. So now to find the value of R, I mean A, we just divide both sides by 3, and here 3. So 3 cancels, remain with A. Then 3 and 2, 21, that is 7. So mean the first term is 7. Okay. Right. Now that we are done with question 1, we proceed to question 2, which says find the 6th term. So 6th term. So we use the same sixth term, we use the same nth formula. So nth formula is, okay, so in this case we know that sixth term, so it simply means the value of n is equal to the value of n is equal to 6. Then first term we found that it was 7. Then R we found that it was 3. Okay, R we found that it was 3, and then A we found it was 7, and then N is C, the position of the term itself that we want to find, that is the 6th term. So from there we just now replace. So we have T, put this guy in, we put 6 equal to A is the first term. So we have 7 multiplied by 3 raised to the power 6 minus 1. So we have T6 equal to here, make sure to work on the power before multiplying these times. That once you multiply this one times this one, it will be wrong. So make sure to work on the power first. So we have 7 multiplied by 3, 6 minus 1, that is 5. Okay, so we have now remained with 7 times 3 raised to the power 5. So again, don't multiply this multiplied by that. First work on the power again. So in this case, let's 3